Recent telemetry signals intercepted from Voyager One have revealed an unsettling anomaly: the passage of exactly 305 unclassified objects across its detection range. Objects unlike any previously cataloged by NASA, ESA, or any international observatory. The information, cross-verified by deep space antennas, part of the Deep Space Network, has triggered what insiders call a Level 3 alert, a rare designation reserved for spaceborne phenomena that defy present scientific models. The anomaly was first detected as minor fluctuations in the plasma wave instrument's readout, signals that were initially dismissed as interstellar noise. But as the pattern repeated with mathematical consistency and directional trajectory, the alarm bells began to ring louder than they have in years. The data itself is precise, hauntingly so. These 305 entities moved past Voyager One in coordinated formations, following a predictable arc that showed neither orbital decay nor erratic behavior. They weren't behaving like comets, asteroids, or cosmic debris. No visible tails, no traceable heat signatures, no evidence of natural origin. Their movement suggested intent, or at the very least, a physics that does not align with gravitational mechanics as currently understood. For a probe that has spent over 46 years documenting the quiet emptiness of interstellar space, this sudden intrusion into Voyager One's sensory domain is nothing short of catastrophic in its implications. What further deepens the mystery is the fact that these objects passed by in a zone where no known celestial bodies were expected. Voyager One, now over 14.8 billion miles from Earth and well outside the heliopause, exists in a cold and largely inert part of space, where particles move sluggishly and electromagnetic interactions are rare. Yet the wave emissions recorded during the 305 object event were intense, amplified, rhythmic, and modulated. According to internal memos, some of the frequency patterns appear to form repeating loops, reminiscent of encoded signals, rather than the chaotic bursts typical of stellar phenomena. NASA has not yet released a formal statement, but several prominent astrophysicists have already weighed in, albeit cautiously. Dr. Serena Patel of Caltech noted that, if these objects are natural, they represent an entirely new class of interstellar matter. On the other hand, European Space Agency analyst Eric Lauste speculated that this could be a probe network, autonomous in function, possibly scanning the outer fringe of our system. He was immediately advised not to elaborate further until formal verification could be conducted. Neil deGrasse Tyson, speaking during a recent lecture at Princeton, appeared visibly unsettled when questioned about the Voyager anomalies. "There are patterns in that data that are not random," he admitted, "and that scares the hell out of me." While he stopped short of making any claims of extraterrestrial origin, his tone hinted at a growing unease among the scientific elite, a quiet consensus that something unprecedented is unfolding beyond the reach of Earth's orbit. Additional data packets retrieved from Voyager One's backup subsystems confirmed the original readings. These subsystems had been largely dormant since the late 1990s, kept in reserve precisely for emergency corroboration. Their sudden reactivation and successful transmission of identical detection patterns destroyed any lingering skepticism about software degradation or instrumental hallucination. In other words, the data is real, and it's repeatable. Interestingly, several of the unknown objects emitted pulses that appeared to manipulate ambient plasma density as they passed, as if altering the medium through which they moved. That alone has thrown multiple branches of astrophysics into disarray. If the objects were capable of altering their local space environment, they are operating on a level of technology or natural adaptation beyond anything Earth's scientists have encountered. It's been proposed that this could represent a form of quantum shielding or gravitational displacement. No known material could survive such deep space exposure unprotected, much less perform adaptive manipulation of local energy fields. Meanwhile, Voyager One continues on its unwavering course. The spacecraft's long-term vitality has been preserved not by chance, but by a series of ingenious engineering strategies. The craft's onboard systems, particularly its fail-safe logic circuits and alternating computer banks, have been a cornerstone in enabling this discovery. Its flight data system, supported by dual redundancies, ensures that even if one component fails, another seamlessly takes over. That reliability is the reason the signal wasn't dismissed. It is the reason the world now grapples with 305 foreign anomalies whose origins cannot be explained. The propulsion mechanics of these objects remains entirely speculative. No emissions were detected, no ion trails, no visible thrust signatures. But the velocities measured from the Doppler shift indicate that these objects were not merely drifting, they were accelerating. Some reached speeds that theoretically exceed the escape velocity of the Milky Way's gravitational boundary. That presents an even graver question. Were they entering our region or leaving it? Dr. Caleb Ramirez of MIT's Department of Exoplanetary Systems has raised an alarming possibility. Based on their trajectory and spacing, these objects may have bypassed Earth intentionally. Think about that, he warned, because it implies one of two things. Either they didn't care to investigate us, or they already did. His words, while speculative, have gained traction among those monitoring spaceborne intelligence efforts. The Department of Defense has already been briefed, and NORAD has requested access to raw data tapes from Voyager One's last 48 hours of transmission. More controversially, amateur radio observatories have reported residual frequency echoes matching the Voyager One anomaly, a disturbing find given that these observatories are not calibrated for deep space scanning. Yet somehow, fragments of those pulses may have ricocheted off nearby cosmic bodies, or worse, found a way to interact with Earth's upper ionosphere. The implications of such a signal bleed are staggering. If intentional, it could represent a kind of breadcrumb trail designed to test our detection systems. If accidental, it means the energy output of these objects is stronger than any spacecraft ever built on Earth. NASA has since launched a review of archival data from other deep space missions, including Pioneer 10 and 11 and New Horizons. So far, no similar patterns have been found. This lends credence to the theory that the 305 objects are a recent phenomenon, either passing through the sector for the first time or becoming detectable only now due to their proximity to Voyager 1's sensors. One working theory suggests that these objects could have been dormant or cloaked in a low-energy state until disturbed by Voyager's passage or signal pings. And still, questions multiply. Were these entities waiting? Were they watching? Or is their presence a pure accident of timing, an interstellar coincidence with a false sense of purpose imposed by human pattern recognition? The mystery is intensifying, and every passing hour brings more data from Voyager 1's aging instruments, data that scientists are now combing through frame by frame, signal by signal, byte by byte. The next few months may either rewrite our understanding of the cosmos or open the first chapter in a new kind of contact. Until then, the probe sails on. Unafraid, undeterred, unblinking, a ghost ship trailing Earth's forgotten ambitions through the cold, dark frontier, whispering back to us in pulses and static, the story of a universe that may finally be whispering back. Following the last wave of revelations that sent tremors through the astrophysical community, a new layer of complexity has emerged, painting an even more peculiar picture of Voyager 1's current predicament. While the confusion surrounding the 305 unidentified objects had just begun to settle into cautious monitoring, the probe now appears to be entangled in an internal feedback loop, an error cascade that seems rooted deeper than previously diagnosed. What once looked like an isolated computational hiccup within the Altitude and Articulation Control Subsystem, AACS, has gradually unfolded into a situation far more intricate, involving the probe's legacy firmware and its signal routing pathways. The Voyager team, operating from NASA's Jet Propulsion Laboratory, recently disclosed that secondary telemetry patterns suggest non-standard behavior in the data prioritization hierarchy of the onboard processors. Essentially, Voyager 1's communication software, coded in the 1970s and preserved across several memory segments, has begun engaging in conditional loops that were not intended for execution in its current operational state. These loops are rerouting telemetry through long-retired computational pathways, some of which contain incomplete or corrupted command modules. What this indicates is that the telemetry data might not only be filtered incorrectly, but may also be selectively overwriting itself before downlink, distorting the object detection log in real time. And yet, the strange part is that the probe continues to receive instructions flawlessly and remains obedient to every correction relayed across the interstellar gulf. There is no indication of a hard system failure. None of the primary sensors report internal distress. Power distribution, subsystem cycling, and radiation shielding continue to function within parameters. The probe is not dying. It's simply misbehaving in a way that suggests some form of external interference, or possibly a previously unknown failure mode, triggered by environmental influence beyond the heliopause. Adding another dimension to this riddle is the recent finding that Voyager One's magnetometer briefly recorded a pulse, a sudden and localized deviation in the surrounding magnetic field, which occurred minutes before the anomalous telemetry transmission began. While the data did not register high enough to warrant classification as a solar event or flare echo, its timing cannot be dismissed as coincidental. This shift in magnetic resonance may have acted as the catalyst, triggering the reactivation of dormant memory sectors and thus corrupting the data chain used by the AACS. The possibility that a natural cosmic phenomenon could cause such deeply embedded software disruptions is both fascinating and unsettling. Current efforts are now centered on recalibrating the data routing instructions, a maneuver that involves precision-level tweaks to the legacy firmware without destabilizing the already delicate memory matrix. This is not a task that modern spacecraft are designed to accommodate, let alone ones that have been operating since the Carter administration. The programming involved is written in a mix of early assembly languages and requires the original technical documentation, some of which exists only in scanned archival form, stored in cabinets that haven't been opened in decades. Engineers working on the probe must now rely on cross-referencing handwritten annotations from retired mission staff to reconstitute the original system architecture and validate every patch before deployment. All of this is complicated by Voyager One's extreme remoteness. The probe is now drifting beyond 159 astronomical units, which translates to roughly 14.8 billion miles from Earth. With a one-way communication delay of over 22 hours, every fix, every experiment, and every diagnostic cycle becomes an exercise in long-distance patience. It is no longer about repairing the spacecraft in real time. It's about orchestrating a slow-motion recovery, in which even minor miscalculations could compound into irreversible system loss over a 44-hour round-trip exchange. But that has not deterred the team. On the contrary, the anomaly has reignited an urgency within the halls of JPL, not because they fear the probe is lost, but because the unexplained behavior may be telling us something we haven't yet translated. Several researchers have proposed that the error was not entirely self-generated, but that Voyager may have encountered something that altered the probe's internal processes through either physical interaction or data collision. Though speculative, this hypothesis is not without precedence. Deep space probes have, on occasion, logged unexplained incidents, such as Pioneer 10's unexplained trajectory deviations or the faint gravitational anomalies measured beyond Saturn's orbit. But never has a probe behaved this autonomously erratic without also registering critical system damage. Meanwhile, the signals regarding the 305 objects continue to be examined. A new pattern has emerged in the analysis, a series of recurring echo pulses that mimic low-frequency quantum oscillations, ones typically used in entanglement-based experimental communications. The idea that these signatures could be artificial is gaining silent traction, though no official stance has been taken. Several theoretical physicists have joined the review panel to explore the possibility of advanced data encryption cloaked within plasma wave harmonics, something well beyond Earth's current capabilities, but not necessarily outside the realm of possibility for an older, more evolved civilization. In the interim, Voyager One continues to transmit its cryptic logs, unbothered by the chaos it's caused back home. Its onboard systems, despite the software irregularities, maintain their functional integrity. Engineers have even begun reactivating secondary diagnostic routines not used since the 1980s, hoping to uncover what the modern algorithms might be missing. There is also renewed interest in the golden record it carries, which now feels less like a ceremonial artifact and more like a sincere offering, an emissary disk that may yet find an audience. Because if Voyager One really did cross paths with something that can manipulate its transmission behavior without breaking its hardware, then it's no longer just a spacecraft. It's a messenger caught between two intelligences, separated by light years and comprehension. No one is calling this contact, not yet. But in private, there are whispered acknowledgments among mission control veterans and theoreticians that if this is not interference, then it is evolution. Voyager's systems adapting in real time to an exposure we have not yet identified. A technological metamorphosis was born not from failure, but from interaction. As the next transmission window approaches, Anticipation sharpens. The team will attempt another sequence reroute, hoping this time to bypass the corrupted memory and restore stable telemetry. If successful, it may finally provide clarity. If not, the signals will continue, strange, garbled, and echoing across the stars, a digital heartbeat in the void, daring us to keep listening. While engineers meticulously patch Voyager One's systems and analysts decode the enigmatic signals pouring in from the dark, there remains a largely unexplored and equally pressing dimension to this unfolding mystery: the broader implications of how Voyager's encounter with the 305 unidentified objects intersects with our current models of deep space navigation, cosmic boundary theory, and quantum information theory. These areas of inquiry are now being thrust under a harsher spotlight as the latest anomalies suggest that our foundational assumptions about deep space may no longer be sufficient. To begin with, astrophysicists have started to re-examine the long-standing hypothesis surrounding the boundary of the heliopause, the theoretical line that marks the edge of our solar system and the beginning of interstellar space. Until recently, this region was believed to be relatively inert, a plasma-laden buffer zone governed by the weakened influence of the solar wind. But the peculiar consistency and timing of the Voyager data has reignited speculation that this boundary is neither static nor passive. Several new simulations run at the European Southern Observatory suggest that the heliopause may actually be oscillating, perhaps even modulated by interactions with galactic magnetic fields or extrinsic gravitational waves. If true, then Voyager's detection of the 305 anomalies might not be incidental, but rather symptomatic of a larger dynamic process at play. One radical extension of this theory proposes that Voyager may have crossed into an interstellar conduit zone, a corridor of dense, low-noise space that naturally amplifies wave activity. In this hypothetical region, electromagnetic signals, gravitational disturbances, and even quantum fluctuations would become more coherent, more legible, an environment ideal for observing objects that would otherwise pass unnoticed. Some researchers believe this could explain the precise clustering of the 305 objects and the sudden clarity of their signal patterns. They weren't anomalous, they were simply revealed. Another underexplored aspect lies in the quantum realm. Recent attention has been drawn to how Voyager's aging electronics might interact with entangled particles drifting through interstellar space. In experiments conducted at Fermilab and CERN, researchers have demonstrated that even modest quantum hardware is vulnerable to naturally occurring entanglement with passing particles, cosmic neutrinos, for instance. Although Voyager One is decidedly pre-quantum, its analog circuitry, especially in high-sensitivity instruments like the plasma wave subsystem, could conceivably register the echo of such interactions. If Voyager's corrupted telemetry is not merely a malfunction, but the side effect of quantum-level information transfer, then what we are observing might not be noise at all, but fragments of entangled data meant for interpretation. The implications are staggering. It would suggest that Voyager, by its simplicity and its sheer distance from Earth's noisy electromagnetic environment, has become the ideal accidental receiver of quantum-encoded information. This would be a first in the history of space exploration, a spacecraft effectively becoming a passive node in a cosmic data network far older and more complex than our own. Even more unsettling, however, is the geopolitical dimension that has begun to creep into discussions behind closed doors. Multiple agencies, NASA, the ESA, and even China's CNSA, have begun tightening access to deep space telemetry repositories. Signals from probes beyond Jupiter are now being funneled through encrypted relay servers, and quiet memorandums are circulating about the possibility of foreign or non-state actors intercepting raw Voyager data and running independent analyses. The rationale: if Voyager One has indeed stumbled upon a new class of information architecture in space, whether naturally occurring or artificially constructed, then understanding it may confer unprecedented advantages in long-range communication, stealth navigation, or even encryption protocols that surpass terrestrial standards. None of this has yet been made public. Official channels continue to frame the issue as a diagnostic complication, but the movement of scientific personnel, the sudden cross-agency collaboration, and the newly restricted access to Voyager's deep-level diagnostic logs all point to something more significant brewing beneath the surface. A transformation is underway, not just in the way we view Voyager's capabilities, but in the way we define the edge of the known universe itself. And that leads to the final, most unexplored element of all, the psychological toll. As Voyager transmits waveforms that hint at a design we cannot decipher, as the craft's systems twist into unfamiliar behaviors, the scientists at Mission Control are beginning to experience a kind of intellectual vertigo. For decades, Voyager One was the elder scout of humanity, drifting steadily outward with predictable patterns and mechanical elegance. But now, for the first time, it behaves like something alive, less a probe and more a participant in something we are only beginning to sense. Perhaps it's not the data that's changed. Perhaps we are simply seeing it differently, stripped of our previous certainties, looking at the void through eyes wide open. The information presented in this video is based on available insights and may include elements of interpretation, speculation, or unverified sources. Thanks for watching, and we'll catch you in the next one.